Hello.
Hi, Jonathan.
How you doing?
I'm okay. How are you?
I'm all right, thanks. Yes. Yeah.
Good, good. Do you want to check your screen share?
Yeah. So
Just get that bit out of the way.
I'm working from a PDF. I did not have time to transfer it into PowerPoint.
Okay.
So this is the PDF, so to speak.
Okay.
Hoping you can see that.
Oh, let's have a look. Not seeing anything. I mean, at least the sound's good. We can hear you.
That's a good thing.
I'm not seeing. You're not. Hang on. Let me just check your.
Do I need to? I need to do
Well,
something here.
No, it should be all right. No, I'm screen sharing now. I want to stop share.
Yes.
So you want to
isn't
screen
it?
share.
I have to do the screen share.
Yeah.
Okay.
You should be able to.
I should be able to share an individual file, shouldn't I?
Ah, it's working now. I can see mountains.
Yeah.
That's your. Oh, there we go.
So
there we go. So if you go full screen and then just progress through.
Where do I go full screen then? In the Zoom.
Yeah, in the Zoom probably. So I'm seeing your screen now.
Yes, which is not quite what one wants.
No, we're not seeing it. I'm still seeing some of your screen save.
Yes, I don't know how to turn this.
Can you drag it across anymore?
Well, I'm just going to need to put all of these. I think the main thing is to put all of these into a temporary folder.
Yes, because then it'd be fine. We'd only see. We wouldn't see your
Folder with selection. I'll tell you what, it won't let me do those. Is that one? No.
What about if you pick the whole thing up and move it across so it's on top of those things? Do you see what I mean? No. Sorry, I'm not helping very much. I'm just trying to.
The thing is, I will end up moving this around later, so I'm going to just get rid of all those, and then they're not in the way.
View options. So do you have something at the top where it says view options?
Not while screen. Oh, I see.
Can you see that? If you, and there's a little arrow next to it, and then it says fit to window. Does that do anything? If you, like on mine, it says fit to window. If you do the down arrow next to view options.
I haven't found something which says view options at the moment. No, I've got
next to where it says you're viewing Jonathan Love screen, I've got view options. You haven't got that, no?
No, I've got top to top. Top.
That's not the end of the world, to be honest, Jonathan, is it? I mean, we can see it, I can read it, so you know.
Yes, one can see it, and I can move.
Yeah, so, and there's nothing.
I can move all these things across to somewhere else. So let me move those to here.
Yeah.
And then they'll be.
And then it's covering it, isn't it? Mm.
Okay. And then I can move that to there.
Yeah.
And
then that's fine, isn't it? And And that, yeah, there we go. There we go. We just need to see the top of it, don't we?
There's a,
I think that's fine. And then if you, can you go to, and then you just click through to the next one.
Yes, that's correct. In theory, I can click through to
All
the
right.
next one.
How are we doing for time? Oh, it's 6 o'clock. So if I better go back to the participants. Shall I start letting them in?
Yeah.
Are you okay with that?
Yeah.
Great. I'll take the waiting off. Hello, everybody that's coming in.
Should I still be screen sharing or shall I stop the share?
Oh, you can screen share. We'll just keep it quite relaxed. Everyone's coming in now, and
people want to come in and see the main screen instead of the screen share at the moment.
No, that's fine. We can still see. Can you all see Jonathan down on your screens as well as his slide? So that's good.
Yes,
hello, Audrey. Hi, Audrey.
Hi, Cheryl. Hi, Jonathan. Yes, I can.
I'm going to take the waiting room off now and let people just come in. Great. Sam, we've got father and son here. Hello, Sam.
Hi. Good evening.
Your dad's
Good
here
evening.
Jonathan's run away. Decided not to do the.
Oh,
Can you hear me, Jonathan?
There's an open document on the other
Don't leave
screen.
me.
I'm just closing the open document on another screen so it doesn't bother us.
I don't think I could talk about heritage conservation practice. So.
Oh yes, you could.
Well, I could bluff my way through it, but I don't think it would tell anybody anything they need to know.
Nothing special about heritage conservation.
Right. Well, it's the floor is yours, Jonathan. I'll just be in the background and I'll.
Have we got everyone in we're expecting?
Well, I think it's just gone 6. We've got 13. We're expecting about 25. So.
We're running for about an hour, is that right?
Yes, that's right. So your presentation and then just a Q&A. So over to you.
Excellent. So the frontispiece, I'm an architect and my clients have self-selected me over the last couple of decades in favour of ecclesiastical work and what was a much broader feasibility-based practice. I'm increasingly recommended as a heritage consultant. I don't actually view myself as an expert, and in all truth, I do not support the kind of quasi-legislative protection of conservation function that has come about through the requirement of Historic England and the lottery funders for architects and surveyors to hold some kind of accreditation in conservation in order to sign off the works and draw down any publicly funded grants. But that system exists and we need to understand it and we probably have to take part in it. I actually favour the professional tools that we use in our architectural training all the time, which are knowing the case in the whole, in a sense, knowing the case as well as all the other parties involved, inspecting and reading the detail of the building, consulting the record, finding out what's gone before and why. And then it's possible for us to set a story that other people can take part in narrating. And if we involve those other people, diocesan authorities or funding advisors or Historic England officers early, we can be pointed in the direction of specialists who know some of the technical information that we can't be expected to know immediately at the start of any one investigation. And it becomes our job to create the argument in conservation by analysing and testing what is there, setting up samples so other people can see the quality of the work we're proposing to undertake and the relationship between the understanding of the existing fabric and the necessity to intervene to maintain it or repair it. It's quite important then for us as conservation-based architects to record the specification. It's a little bit like our IBA Part 8 or part 9 even, the idea of knowing later what was done, so that you can see whether something done on the northwest face has survived well compared to something a different specification used on the southeast face. And in all of what we do, I think we have to distrust the past. You're allowed to distrust the past. What you read is not necessarily the right thing to have done. And you can question the wisdom, but not discredit the lessons. Now, today is set up as what do we know? And that's our training as an architect. What do we think? And that's our analysis of what we see. And who do we need to ask, which is realizing that we will always, even if we're accredited, have gaps in the heritage. So I've drawn together 5 sort of case studies. None of them are short, but we'll scamper through. And one is, all of them are based on, it's an amalgam, putting together of lecture notes that I've given in the last few years to various heritage organizations. The question about stained glass, I'm not a specialist in stained glass, but when I look closely and I see bits of discoloration in the glazing in areas, are people able to see my cursor moving around, by the way?
Yes.
Good, thank you. And you see this kind of grub and pollution and you're wondering how far to go to clean it off. Perfectly clear that these things are due to a breakdown either in the surface of the material or in the maintenance of the building. And we need to address that because otherwise we're creating a microhabitat. And what we learn is that if material is coming in through a window, it's because the joint between the glass and its bonding has failed. Well, I took over a report from Austin Winkley at St. George's Cathedral where he talked about buckling in the window, and it took me a decade actually to see it, but you can just about see a buckling pulling out here and a pressing in there, and then suddenly one inspection I noticed that the whole panel was pushing in, and so that's the point at which his warning had come to a point of failure and we needed to do something about it. And in this instance, we were able to analyze that part of the problem is to do with the way there was nothing to let the water run away from the edge of the panel where it met the stonework, and that was deteriorating the edge of the panel. So we're just using our eyes to feed what we know. And then we proposed adding a little fillet, and that fillet effectively covers the edge lead work. And by covering the edge work, we've slightly changed the appearance of the stone, but we needed to explain that the detailing of this stone with the ledges that were entirely horizontal didn't match the medieval detailing. This is a post-war rebuild, and therefore you needed to throw the water away. And the authorities allowed us to add this fillet, which apparently changes the weight of the stonework, but not when you read the overall scale of the window. So that's why I say distrust the past and use the virtue of one's eyes. This is the York Minster east window before the window is going back in on the inside. And a large amount of money has been spent on exploring glazing that would have a different character to it, but the leading follows the lines of the principal figures of the medieval glass, and the medieval glass is going back on in the inside. And again, it's that question of, do you do a large piece of float glass or do you try and get the impression externally of still a leaded light? I'm going to ignore the Gerhard Richter at Cologne Cathedral because it's not relevant to us. But this question of the external effect of climate on the structures that we create, we can really, just as architects, read with our eyes. And you can see that there's a wind pressure problem here and that this dalle de verre work is pushing in. And we need to ask ourselves, why would it be pushing in? And we just know about thermal expansion. We know about solar gain. We can see that these fins are going to create a shadow as the sun comes round that will cause this area to expand earlier in the morning, this being a south-facing facade. And then gradually, as that expands, this will not. and you get this cracking forming where the matrix of the window is being affected. So if we don't intervene fast enough, then the net result is that your window or your fabric lands on the ground. And if it lands on the ground in a tiny and insubstantial parish church such as this, without a listing, then the result is the total loss, because no one has the money to put it back. So we need to be brave and intervene to save the art, even if there isn't a proper conservation option to us. This is St. Lawrence in Catford that we've been looking after for 20 years. And we find that the large dark blocks crack here, and it's because the large dark blocks, they gain heat and they expand faster than the concrete matrix. So they're cracking against the matrix. You see that there are tensions within the format. These are small pieces of concrete that will move not very much, and then suddenly it joins a large piece of concrete that will move much faster as it warms up. And this is, in a sense, an error in the capacity of the designer to recognize what's going on. And then the maker has chosen to mold the glass and cut it out with 3 sides square and 1 side nibbled. So when that starts to push in, and several of them push in, we can read the fact that the smooth edge is not going to create the bond. And we can also read that if the whole glass is moving, the whole pane is moving separately to the support structure, then this is what happens when nature gets in. Well, on this particular church, it is a listed church, and the terribly narrow concrete mullions, which have worn many times, have warped. There's a single bar in a 5-inch concrete, and it doesn't have enough cover. And we felt that these same problems exist in Sir Basil Spencer's Coventry and Sir Frederick Gibbard's Liverpool Metropolitan.
I suspect this, even though he did a massive pool.
On the floor?
No, in this nappy, and I just thought I couldn't actually see it.
Yes.
So I just
Someone would like to put themselves on mute, I think.
So be careful there.
Is that on mute? Thank you very much. And so this is a small parish church, but it sits in a panoply of buildings of the 1960s and 50s with Dal de Verre. And so we can turn to ask what people are doing elsewhere. What we know is that it's failing. What do we think is that it might not be possible to restore it. We can, I've got 2 of those. The failures allow the water to come in, but what we couldn't be sure is whether it is genuinely rainwater driving in or condensation. So certain tests can be set up where we set up a channel here to catch the rain, if it were, and to see where it's running through. And we found that very clearly there is rain coming through where we don't have a channel, and where we do have a channel, the chalk line is not being removed. So we spent time analysing what we're seeing, and we wanted to be sure that it wasn't condensation. And we were able to check it wasn't condensation by a variety of positioning of the chalk lines and the collection channels. If we're going to talk to someone about the building that we're going to conserve, they're going to want to know the significance of that building. And so, for example, Ralph Cavell, who looked after St. Lawrence Catford, we found that all of his work fits in the zeitgeist of the time. And we looked at, and we proved on a number of sheets how his work, though considered lesser than, is of its period, and therefore he is relevant. It's important to look after him. And we were able to talk with the major companies and find out what they were trying to do with their churches that they were looking after. And there were hundreds of thousands of pounds going into research at Liverpool. But I was convinced from their explanations that they weren't getting very close to solving the way in which water is coming in. And the pressure is there to say, well, are we going to collect the water, allow it to come in and take it back out again? And it's important to realize that we don't have to do everything as a formal drawing. You can communicate to the authorities much more easily with a sketch. We didn't know whether we would want to take the water outside or not initially, but our investigations found the amount of water coming in dried out of the channel. But our preference was not to let the water come in, and we made propositions about an external glazing. This is simply using what do we know, i.e. that you can't keep the water out. What do we think that it's worth keeping the material, and who should we ask? Well, both the conservation authorities and the technical people. The concrete is failing for all sorts of reasons, but there are tests which enable you to find out what's going on. And if you ask the concrete testing people and the specialists, such as John Broomfield for concrete, and the manufacturers who are making different forms of concrete, we identified the carbonation. We identified there was no way other than covering it after treating the rust to afford a repair. And we were able to say to the authorities that this was not going to be a conservation-based approach using exactly the same mix of concrete as the original, because it was not serving the purpose. And we weren't going to be able to leave the mullions exposed in the original concrete either. They needed to be surface covered. And it's that persuasive argument, the technical, the significance of the architect, and what other people are doing on with larger budgets. And if they're not succeeding with larger budgets, then we have to hold back, make the obvious repairs, cutting out, and then propose a way of keeping the water off. So unusually, we simply have frameless glazing. The conservation approach is to protect the art until there's some future technology that tells us how to stop the water coming into the Dal de Verre. But until then, we're protecting the water from preventing the water getting to the heritage. And you see here the previously painted attempts, the repairs in the concrete, the repainting with a more sympathetic color so that it went back to the tone of the original concrete, and then the glazing going in place. I mentioned setting the story, telling the story. This is St. George the Martyr at Borough. I wonder to what extent Renzo Piano looked at this view in choosing his angle, because there's a point when this exactly covers that. But understanding its position, its microclimate and its heritage, and looking at what's going on inside and what are the significant things. Looking back on the data from previous attempts, this church has been underpinned, and we know from the data that they ran out of money and couldn't finish the work on the parapets that they had hoped to do. But we knew that it was stable. So we found from the archive that the cracking and so forth was not going to go anywhere. And an engineer gets involved and shows us that. But we can see from the sketch detailing that the external water is extremely close to the internal face, and we need to get that to drive out of the building and not into the building. And we can tell the difference in the side sacristies of rain coming in and that streaking, as against dark mold forming and damp patches, which is moisture in the main zone. So again, using our eyes at what's going on, we looked at the parapets and found movement cracks, but we found frosting as well. And initially it seemed logical that that would be related to poor brickwork or hard mortars that had gone in the past. But when you look closely at the back, you realize that there's a lot of stuff going on the backside, because it's driving. Someone has tried to stop water getting into the parapet, but they're driving the waters in. So what do we know? We know that there's some more modern render here, just of the last 10 years before we came to it. And there's some older render. The old render is so hard that it's uniformly damp all the time, water that does get in, and it grows mold. this is not uniformly hard, but the water is percolating in and finding its way out in patches. There's no other explanation for this grouping. Just use your eyes and say, this is failing through a mechanism that we don't yet understand. And when we draw the structure through, we can see that the attempts to put render on is actually keeping the water in. You can see there's no drip molding here to stop the water going out. And we can see that when it gets to the bottom, all the work of our predecessors is stopping the water getting out and forcing it on down here into the attic void, because they've also mortared this up with hard mortar, stopping it getting out again. This is the technical specification that we're using as modern architects anyway to enable a thing to be breathable. So what we're looking at tells us what's going on. We then find that people have come back and patched in unlikely materials, so the two are moving, you get cracks. Other people have tried to keep water out with bitumen, so again, you've got more than one specification. None of these are going to survive one against the other. And when we look, we find that the actual brickwork behind is just letting water pass through. What do we know? That it's leaky. What do we think? That the water's being led into the wrong place. Who should we ask? Well, we need to start doing some tests. And I have to say that's an terrible piece of masonry work of cutting out some render. And you have to read the Riot Act if your conservation contractors are willing to damage the building in that way. So they became a little bit more cautious. You start to see there are patches of soot and bitumen that other people have used. There's a mix of different brickwork. All of that says you can't really hope that this brickwork is going to give you a decent finish in the future. You can't just re-inspect it, re-expose it and hope to point it up. Now we know that from the tests, and we offer to the heritage people 3 or 4 ideas. One is just to render it again, but that's repeating the same problem as 2 or 3 different render specifications have given that it fails. Another is to put up a board, but it very soon became clear that these boards, firstly, they might sweat inside the cavity, but secondly, cutting them to follow the profile and the irregular character of slight curvature and so forth would be difficult. You've got a different zone in the brickwork plinth. So we were able to propose that we would render, but we would render on a spaced off mesh. And that render would take all the effort of the wind and weather temperature change. And we would open up the parapet face with softer mortar. We would introduce the drip. We would recreate, we would introduce a cover molding. But you can hypothesize that at night, this is going to get cold sooner than that. And so condensation at night will go on to the back of the render surface. And in the day, you can hypothesize that this will get hotter by day than the brickwork, and it will enable airflow to rise up through the cavity and back out again and lift the moisture of the night off the cooler surface of the brickwork. You can hypothesize that by preventing the backwork receiving water and making the front more breathable, your water is heading outwards before it heads into the building below. And as we start to get permissions for that, you then open up more and more and you find exactly what you feared, which is that the water is just landing in here, finding its way through very open brickwork and not getting out where other people have attempted to keep it dry with bitumens. So what do we think? We think it's leaky and we think the water's being retained and then forced out under the wrong environmental conditions. Where did we get to? Both on the front side, we improved the drips and the water leaving. There's different details around of some brick walls and some bottle balustrades. And we had discussed all of that with the diocesan advisory architect first, and then it had all gone to Ian Harper, the Historic England representative in London region. But we set up very early on the main works, all stages of the work on 3 different sides, so that he could come once and inspect and make his comment before we'd done task 1 everywhere, or before we'd done task 2 on top of task 1 everywhere. So we showed him task 1 of clearing out, setting up the mesh. We showed him the early stages of render, and we showed him the drip moldings, so that he could see on his first inspection that it was going to run to program, as it were. Now, moving back to the cathedral, a very similar story, but a different analysis. This is the mother church of the Archdiocese of Southwark, stretching down to Dover. It's necessary to understand why it behaves as it does. It's been built a little bit after the development of the fields in London. This is Borough, this is Westminster, this is the Tower of London, this is the development in the mid-1700s as a ribbon, and these are the parish lands of the old parish of St. George the Martyr. By the time the cathedral is built, there are new roads being laid out, but we're effectively on virgin territory of agricultural fields, and the cathedral arrives in here at a time when that road is driven through. So we begin to understand why it's on a patch of field, why it's on a single patch of geology, and we're able to talk with the authorities about the Pugin building having been firebombed in the war, about the rebuilding of it with a higher nave and the fatter set of columns. So we began to see that there's fresh work at the top of the Pugin walls. And it's that fresh work which gives us cause for concern, because it's all mobile and the mortar is dropping out. So why would the 20th century mobile brickwork be flexible, losing its mortar in a way that the 19th century mortar is not? What do we know? We know it's moving. What do we think? There must be a difference in the way it's constructed or its composition. Who should we ask? Well, the answer is we have to ask the people who understand the materials. And that involves getting permission to harvest some samples and sending them off. What we found here is that post-war materials we've noticed elsewhere are in less good nick than pre-war or late 20th century. This is mud that's been dug up rather hastily, and there are embedded nails all the way through the 20th century brickwork that split the face off. We've also got the difference in the 1848 Pugin mortar, where it meets the 1958 bricks, which is set in a softer mortar. But we don't know what that mortar is, and we don't know about the bricks. So we send off the 1948, the 1848 and the 1958 bricks. And this tells us that apart from 1 or 2 anomalies, we've got average strength of bricks, but they absorb very differently. So the Victorian bricks are a much more consistent, tighter pack, and the modern bricks are much more open textured. And you can see that we then have brick samples cut through and strength tests done as well as absorption. And the post-war bricks are just more porous. So they've allowed more water in during the construction period. We similarly can analyze the mortar and find that actually, in theory, the modern mortar is much stronger than the 1948 mortar, but it's just broken down and become very weak over a period of time. It also doesn't have the same range of particle sizes. In other words, there's not a good meshing of the small fines around the larger particles, And so it's been a more open textured mortar. All in all, you can hypothesize that if it's more open textured, it's been letting more water in. But we're also say, well, that's not enough to know what to specify in its place to put more mortar in, because we don't really know the chemical composition. But we can predict that if it was built in 1958 during smog conditions, I mean, the Clean Air Act is 1956, but there's still a lot of pollutants in the air and so forth at that point of the building. We do discover chemical changes due to sulfurs and other acids in the construction water or in the rain that's going on the materials that were being stored. And we can see where the spikes are of different chemical formations that have effectively stolen the bonding capacity of the mortar. Now, I don't know any of this. I'm just an architect. But once you start talking to the people who are doing the tests, they guide you through, and the conservation becomes answerable through an analysis of what they're finding, that the material is too breathable, that the mortar has become weak very early on, much of the cement has turned into plaster and gypsum, and that's got to be addressed. And what we found is that we were able to agree with the heritage authorities a much weaker pointing than you would normally expect on a parapet. Because if the interior bed is all flexible and weak, and you put a harder, even as it were, an inverted commas soft but modern mortar on the outside edge, then that mortar will become the support of the whole brick as the rest of the bed remains flexible. And the edges will take too much stress. You just know that you've got to go for something softer that is going to seal the joints but breathe the water out again and move as flexibly as the remainder of the bedding. But we're coming to a different little story. You can't always be working with new brickwork, and you can't always put new stonework in. And a way of looking after the stonework, again, it's using our eyes of what's going on. I've noticed a lot of colleagues, when there isn't the money to restore or replace features, this is the internal walls of the ruined Hardwick Hall. This is not one of my projects. This is an English Heritage project, I think. But there's a tendency to shelter coat, to try to get the surface of limestone, where it's deteriorating in climatic conditions, to stop deteriorating. Well, I just noticed my colleagues are spreading this lime on like a slurry, and it's not bonding, and it's removing some of the evident detail. And that seemed to me something we can look at and say, why is it doing it? And what is the way to stop that happening? Because to put this on and have it flaking off 2 to 3 years later is ineffective when you need a big scaffold to get up to this stuff. So again, with conservation people, we looked at an alternative to how do you get the surface of the stone to be protected and to start to re-harden behind the protective surface. This is Hardwick Hall, and this is work that we're doing at the cathedral. We're including earth colours into the lime shelter coat in order to tone it down as well. But what we found is that you need to get the new material to bond on to the old material. It's literally a modern process of using a primer, but you're with compatible materials. And we found that by pushing the material on instead of brushing it across, we could get a better bond. We could get a better color choice by using the pigmentation, and we could get a better stippled match to the texture of the surrounding host stone. This is our 2012 brush coat of the the bonding, just to see whether that was creating an effective hardening of the surface by re-enlivening the stone. And 5 years later, 3 years later, it had. And 6 years after the stipple coat, this is the same patch, lasting very much better than what we could see was not lasting before. So what do we know? What do we think? And who do we ask? And some conservators helped us build up this mix of materials in terms of the lime and 3 different sands and dusts, stone dusts, to get a mix that would create this stippled effect. And we've been able to run that across, not always with the color matching, which is time consuming, but all of these have had in 2015 that stipple coating to stop the loss of material. And you can see that the stipple coating begins to host the same sort of fauna and bacteriological and pollutants that are landing onto the surface of the host stones, so that the repair is beginning to match in. And I think we have much more visibility of the remaining detail. The little question we're going to come back to as to why would some parts of this stone deteriorate and other parts would not. So that iris there that my cursor is just running up is almost as sharp as it was originally carved, whereas self-evidently bits around this collar, this bit that is peeling away, are not behaving properly, and yet it's all the same stone. But we'll just give you a little close-up of the new brickwork at St. George the Martyr. And what we realized is that if we knew how to shelter coat stonework using lime, we weren't sure how to shelter coat bricks. Bricks, if they've lost their surface, will frost and damage, but you can't always cut in a new brick. Sometimes if you've lost too much of the surface but far enough back, you can build it up with resin brickwork and dust. But sometimes there's not enough to build up, and yet you don't want to disturb that bit of wall around it, and yet you've got this exposed. And we realized that there are perfectly good mineral paints that are going on to renders and brickwork all over Northern Europe. And we've started to put in a little pattern of stippling on the mineral paints to the broken bricks. So we're trying to get a way to protect the surface of brickwork at the same time as protecting the surface of stone. Sometimes we come to the stone and it's just gone too far. That simply needed a finger's touch and the whole U of Sanctus, Sanctus, Sanctus fell off. And this significant inscription has gone massively too far. I find it intriguing that in the same piece of stonework, there's the joint, there's a piece that's dropped away, and there's a piece that's eroded, and the next joint is over here somewhere. Here's a different joint. It's all the one inscription. That's turned black with sulfurous gypsum surfacing. Some of these have barely altered in their lifetime, and some of them have eroded away, but not turned black. Again, the chemical people, we asked the question, because this yellow stone is a calcium carbonate. It's exactly the same stone, exactly the same period, but it's developed very early on a calcium carbonate face that goes slightly yellow, and these have not. And we've asked the question, what happens to take your calcium carbonate, or rather your CaCO3, this is the calcium carbonate, this is a calcium oxalate finish. And the oxalate is very firm. How do you get to the oxalate from the bare calcium carbonate? And we start to ask the question because we have circumstances where we can't afford to cut this out, but we want to stop it eroding more. And we have circumstances inside a bell tower back at St. George the Martyr, where getting up to it with a scaffold over the bells is difficult if you were going to do stonework, but not difficult if you were going to consolidate the surface. And we tripped across the fact that in Malta, where they have massive marine erosion and very uneven erosion of different blocks, they are investigating the use of aluminium oxalate treated onto the surface of the calcium carbonate, and it is creating a calcium oxalate. So we've been in touch with them. You can see that in Malta they have two very different stones. This stone doesn't greatly worry them because they don't lose the structural integrity of the stone very fast. This stone does worry them because then they're constantly coming in and patching up new bits of stone, and they want to find a way of just stopping that deep erosion happening. And the calcium oxalate is turning out to be a way of working with this, creating the consolidation of the surface by converting the surface rather than adding something onto it or paring it back, is turning out to be effective with 3 or 4. They've studied 3 different classic environmental pollutants: salt, sulfates, and nitrates. Well, we're moving on to realizing that if you're looking after the external fabric of the building, there's a whole story about what is the internal climate of our historic buildings. And Tobit Curtis is beginning to investigate that internal climate. We're busily as architects trying to heat and ventilate and light and service our buildings, and we don't really know the impact that it's having. St. George's Cathedral back here, it's a perfectly normal structured building, the ancient walls on the outside, the modern pillars that, because they're fatter and carry more weight, are sinking slightly into the ground, giving us cracks. The two join very nicely and very neatly, very effectively, and it should be a good internal environment, but we're beginning to get trouble. When I became architect in 2003, there were hardly any services. There was an underfloor heating system, a few hardwired microphones, and a bunch of hardwired lamps and some loudspeakers. Everything was solid state, including the organ. And since then, we've put in new heating controls with wireless communication from Cathedral to the control panels, all of which runs on battery. We put in new lighting, but these control systems are failing after less than 20 years, and they don't run the same, the new replacements don't run the same type of light, and the new type of lights, the LED ones, need a different dimming system. But these whole units, you don't replace the bulb, you replace the whole light system. And because replacing a light system involves screwdrivers and the like, we can't get at them off A-frame ladders. So we're now bringing in electronic scissor lifts. We have an aspirating system with filters and batteries and wireless controls, all of which is serviced twice a year. And we've got a loudspeaker system and an induction system with wires under the floor, and then you find that one set of TV monitors are on a different signaling system and the cables get changed. All of this is a lot of intervention and a lot of travel to and from the site for the maintenance of the kit. We have television units which have all been changed once. And this red is a list of the things that have changed just in 20 years since we started to make the environment in this building more suitable for modern expectations. People want to take their coat off. They want to be able to see what's going on beyond the pillar. They want to be able to hear at the same time. So these loudspeakers have been changed for those ones because they didn't have a time delay and these do. And people complained about the flutter. And when in our historic buildings we start to adjust to our modern expectations of commercial life, we're beginning to fill the building with equipment and systems and interventions and maintenance that do not save energy because our energy footprint has gone up, that involve maintenance and that have unforeseen little effects of adding heat into the building and driving air currents and so forth. So we're starting, because the cathedral wants to undertake a series of projects to monitor the environment, and we started using with Tobit Curtis and Associates with an infrared survey to look for the places where we've got heat, cold, damp, water, and so forth. We need to look at whether the sanctuary ceiling that has an air void above it, the only part of cathedral that does, is driving a pattern of pollution and hot and cold currents going into the organ. We need to look at where we replaced and cleaned some plaster after dealing with the parapets that I mentioned. We intervened with a balcony that gets us from one roof to another for inspection purposes, and then found water running across. And we don't know whether that's rainwater or condensation. It could be significant amounts of condensation in that particular part of the roof. And so we need to monitor that. The air for the organ goes in from the building, which has got pollutants of grime, incense, pollen and so forth, runs through past the instrument, in from the cathedral, through the instrument into the organ blower. It gets sucked into the organ blowers and then blown into the wind chests. So the organ builder becomes part of our analysis system. He understands what's going on with the instrument, and he starts to ask us to address the environment. But he's looked after this instrument for 18 years. This problem wasn't there in his first 10 years. It is there in the last 8. And so we have to find out why are our temperatures going up too much, and what are the airflows through that are having a detrimental effect. So we will be monitoring the air inside and outside, and we'll be finding out to what extent the roof is insulated, because we know that the walls are well firmly buffered. But it's not just the winter that we're dealing with. In the summer, the heat in the instrument is causing these tiny bits of leather on these small little book-like valves. They react to all the electronic instructions from the console, and they open the air into each and every valve, depending on what's been called for. Those are warming up, the glue is melting, and they're slipping in the summer. So we know we have to intervene, but we don't know precisely what we've got to intervene with, so we have to ask before we intervene. Because that particular organ blasts the sanctuary before it gets down to the end, the organ music department want to put a new organ into this zone of the cathedral aisle, where the lady chapel behind would act as a sounding box to the organ. So again, we'll monitor the solar gain, the airflows, the temperature and humidities in this zone before designing an instrument to fit in there. Cathedral wants to install a new stained glass window, but we know from Tobit Curtis that the impact of even small amounts of stained glass affect the performance of the glass, its heat expansion and the like. And we also know from Tobit that if you're going to put fresh glass inside old glass, you protect the new glass, but you need to know what's going on in the cavity. So once again, he will be monitoring the conditions at the window, looking at what happens with the external sun angles when these trees are pollarded every 10 years, then again, the shadowing effect is a variation. So we need to propose something which copes with those diurnal and seasonal and periodic changes. Once we start to draw what's going on, we can start to let the designers and the other people into the possibility of installing a frame into the original groove, and then the existing glazing going back into the frame, and then the new glazing being on the inside supported off it. But if we look, if we draw, we can ask, and if these arguments all come together with the background information, we can know that the authorities will come with us. They're looking for an understanding of the fabric and a reasoned approach to the conservation and the alteration of it. I'm going to skip over the doors because it's self-evident. We're looking at the doors. If they're left open, you get huge temperature and humidity changes. If they're left open because the porch is too small for numbers of people coming in and out and too narrow for wheelchairs, they will be left open. So we have to look at the wind effect. We happen to know by talking to places like Ely that when they installed an inner lobby, this is a proposal for an inner lobby at St. George's Cathedral, but when they proposed one, they installed it, they got a different scouring effect directly outside the window because part of their lobby set out into their porchway, and that change in the wind eddy affected the medieval carvings within a 2 to 3 year period, just a different scouring effect. So again, when you propose this, you ask people who had a go at it already. That shows me as architect the things I'm going to have to know before I can progress the client's thought. What I find interesting also is when you draw it early, however unexpected the design may be, other people can start to come in. And here we've been told to be braver. The suggestion is, our suggestion was that by putting a small box in here, these doors could stay open all the time, and we would get a 4 to 5 meter travel between the outer porch and the inner porch. But it's been proposed that this is a kind of halfway house. So if you're going to keep that set of doors and allow them to be open, then why not remove that entirely and do all of the intervention within the narthex? We're not decided yet because we're still going to collect the data on temperature, humidity, wind and air movement, and that will then assist on the design of the lobby. I'm going to skip over the fact that we've done all the parapets. We've enlarged all the overflows, and yet we're still getting water in modern conditions. And the client wants to recreate the Pugin paint scheme that was lost in the war. And we obviously can't recreate that Pugin paint scheme if our parapets are not yet resolving the ingress of water. A quick overview of what Tobit Curtis will be doing. There'll be a series of data collectors for temperature and humidity that will bounce their information wirelessly to a receiver within the system. It will go through the cathedral's network into the internet and arrive at their offices on their computer system. And they'll be taking data at 15-minute intervals. And at the same time, they'll be measuring what's going on outside so that the relative humidity and the absolute temperatures outside can be compared with the spikes on the inside. And the locations, by using wireless equipment, can be put up. And if in 3 to 4 months they're finding that 2 of these are giving almost identical readings throughout a period of a day and a week, they can make use of one, move it to a different position until we're getting to key variations around the building itself. So I'm back to our do's and don'ts. The architect wants to know the case in the whole. We don't have to know all the detail at the beginning, but we need to know the case from everyone's perspective, including the heritage authorities and the funders, almost better than them. We need to demonstrate that we've been inspecting and reading the detail of what's physically there in the building, and that we've consulted what's gone before us to understand why some things may have failed and others. Then we can set the story of the objective, the difference between conserving, restoring, or replacing, And if we set that story, the other people can become involved and take their share. And if they take their share, I find that they tend to approve because they've given that information to us. They and others, if we ask the right people, point us in the direction of the technical specialists for specifications and for tests. And that gives us a fundamental basis for creating the argument in favor of a piece of work that the client wants to achieve. And having created the argument, the analysis and the testing goes forward. We set up our samples that other people can come and look and see what they can expect to get when they've given you consent. And once we've got the consent and run the project, we need to keep a record of what we've done where, so that we and people after us can watch the performance of it over time. And with that, I'll leave this screen up afterwards while we're chatting, just because we'll come back on this. Just want to say that I am extremely worried by the amount of money we're spending at Cathedral redoing overflows and renewing electronics that have all been done in the last 20 years, well, 20, 30 years, including Austin Winkley, on overflows, just because of climate change. And if we keep messing up the rivers and the watercourses, we shouldn't be surprised if the mermaids start messing us about as well. So thanks very much for listening and not intervening.
Thanks
This
very
slide-
much, Jonathan. Thank you. So open for questions to Jonathan. You have to unmute.
Thank you very much, Jonathan. I'm not sure whether you can hear me. I'm at the station, so I hope you can hear me.
Yes, I can hear you.
Yes, yes. I just heard you mention the effects of climate change. I mean, I hadn't even realized, just thinking about environmental issues as they are, but now with the effects of the obvious effects of climate change, there's even more to tackle, and if you can elaborate a little bit on that, please.
Yes. So the sheer volume of water that comes down in the flash floods, even though you may have cleared your gutters and unblocked your drains, we find it ends up with standing water in the pipes. And effectively, the water isn't leaving the outlets above. So what we were doing was putting in overflows for the times when the gutters got blocked or the outlets got blocked with plastic bags or coffee cups or a dead pigeon. And those overflows, though they're big enough to take the volume of water of a normal rainfall, then neither the outlet, the original outlet, nor the new overflows combined are coping with the volume of water that comes down in a 4 or 5 minute period. So we're getting rain internally. The second thing we're finding is that the external temperatures in the summer mean that the equipment inside the building is not cooling off. So the quality of electronics coming out of China mean that organ controls that used to last 30, 40 years last 7 or 8. But if you put them into temperatures above 25 or 30 degrees, they fail even more quickly. So the boiler control cards and the control panel electronics have failed in our boiler room because in the summer, the external air temperatures are 30 to 35, and the internal boilers, just dealing with the summer hot water load, are creating an overheating in the boiler room. So where we used to be thinking that we're heating for a background set of winter temperatures and designing our water outlets for a background of heavy winter storms, that's all turned on its head. And the impact of water and heat inside the fabric of the building, when it's got into the brickwork or the masonry, when it's got into the timbers, when it's not breathing out because of high humidities in the summer, is affecting the way in which the buildings are performing. And I'm honestly beginning to think that we have to be much more clever about not putting electronics into historic buildings, not putting systems in that involve 2 or 3 maintenance visits per year, not putting in new equipment just because if we change the lighting, it will be cheaper than the previous lighting or our energy use will go down. We need to husband our resources for the actual work on the fabric, making the fabric perform. And that's a learning curve at the moment. How do we make the fabric can perform in our current climatic conditions? So they haven't experienced those conditions before. This page, by the way, has got 3 things on it. One is that the RIBA is running a conservation register. They set one up, folded it in favour of AABC, and then set up their own competitively. But the RIBA and the Register of Architects Accredited in Building Conservation. I've learned what I know about conservation by attending conferences when people are talking at things. And so COTAC, believe it or not, COTAC, the Council on Training in Architectural Conservation, was formed in 1959. I only heard about it recently, but their forthcoming 2-day conference, both online and physical, is Climate Change in the Built Heritage. There is, of course, SPAB, but I also recommend this amazing interview with Julian Harrop on the RIBA journal website. And he has this lovely little quote: "The profession was educated and posed as the artist in the attic, isolated from the life of the building they presumed to alter, adapt, and reconstruct. It takes about a decade to educate an architect sufficiently to overhaul, repair, and extend an 18th century house. Sustainability is a direct confrontation to the builder's merchant who is ill-equipped."
Thanks very much. Thank you, Jonathan.
I strongly recommend reading Julian on that.
Sorry about that, Jonathan. Any other questions for Jonathan? You need to unmute if you want to speak, and it might be nice to start your videos as well. Practice what I preach.
I'd just like to say thank you. I put in the chat, it was a fantastic presentation. I've learnt more in the last hour than I have in the last month. And I feel like I've earned for the first time, I've earned my CPD points for these lectures. It was fascinating. And a forensic analysis of the buildings, you know, I think that's what comes out, that it's the scientific investigation of everything that leads to the artistic interpretation of it. It was fantastic. Thank you.
Thank you, Chris. I do want to stress what I say right at the very beginning. You know, I started in practice a much wider range of clients, and people came to me, yes, a slightly forensic analysis for buildings or sites that were not viable or had failed to get a planning permission and the like. But then gradually, the last 12 years or more, it's the churches who stay with me and everyone else has gone down a different route. I just don't think that conservation is special. What Julian says, it takes about 10 years to educate. Well, frankly, if you're going to go into leisure, or if you're going to go into hotels, if you're going to go into tall buildings, it takes a period of time. And I regret the idea that somehow conservation involves a particular approach. Any architect worth their salt are going to listen to the story in the round and find arguments that satisfy all the people who have a control over it. You can only do that by applying what do we know, what do we think, and who on earth can we ask to help us know that we're on the right path. And the forensic analysis comes from that. If I go to some conferences and people are doing something I didn't know about, then my next opportunity is a chance to try doing it and find out what we learn. So I just really want to stress this: knowing the case, inspecting the detail in the record, and then it's our job to set the story. And that's true whether it's a hotel, sports field, private house, or conservation of historic fabric. We can all do it. We just have to believe in it.
Jonathan, I think you downplay your specialism by saying that. I mean, I got my accreditation under the new RIBA Conservation Architect scheme a couple of years ago, and yeah, that partly came about from frustration on trying to deal with conservation officers who were looking down their nose at me. Yeah. Being a young architect with a young practice, kind of like, what do you know? And I got fed up with that, and I thought, well, I'll just go and get some letters. And yeah, it was great to go and sit on that course and actually find out that probably about 80% of what we were doing was exactly right. But I have to say, it was a real eye-opener and a real learning for me to learn from some more learned people like yourself about these sort of wisdoms of approach. And I have to say that extra 20% that I learned in doing the course has probably added about 80% of value to my knowledge. So it's interesting. I think that there is definitely merit in these schemes, but yeah, ultimately, as you say, it does come down to some key philosophies. It's very interesting to hear you talk.
So it's something like you. In the end, I went and got the accreditation because my clients deserve it. If my clients are going to have to appoint another external advisor to draw down the grant that we've won, that's not particularly fair.
Yeah.
I don't want to downplay the skill that is accumulated over time. I simply want to downplay the suggestion that in somehow certain architects are suited to conservation and looking after historic fabric. I want to draw the parallel. If you were going to renew some windows in a 1970s housing block, you would go and look at the compatibility of the new window and its junction material and how you were going to tie it into the existing fabric of the building. And you wouldn't put one in that was likely to move very differently, or you probably wouldn't try and put in another gasket that would fail after 10 years in the way the first gaskets failed after 10 years. You just use that mindset to look at what you're doing. Similarly, you probably wouldn't do an external glass structured canopy on the front of a stone-clad building in the city without allowing for movement and different performance in the materials at the junction. When you're designing something new, the same approach applies with the historic materials, but you don't introduce an unusual mortar that's the different strength and the different size. You don't put in a piece of sandstone where it's a piece of limestone. And you don't chop out a piece of material that's functioning okay, but is got a corner cut off. You try to stop that corner getting worse, as it were. Just use the eyes. That's that phrase, inspect and read the detail. And it's just the processes are not subtly different. The understanding is subtly different. And I've gained it over the 12 or 15 years of being just in churches. And before that, extending buildings for Grosvenor or Greenwich or Royal Arsenal or whatever from time to time.
Mm.
Gain it over a period of time, yeah.
So what accreditation did you go for?
I went for the AABC because it was in the period when the RIBA had stepped out of the field.
Right.
I have very little good to say about the RIBA, so but yeah, they stepped in the field and then they stepped out because it was financially not very valid, and then they realised it was all growing market and they stepped back in, and so there were two different registers, and it's not necessary.
Yeah, right. Yeah, I agree. I think, to be honest, in my dealings with the RIBA, the conservation team stand out, actually.
Yes, I think you're right. I think you're right.
They're pretty good. Yeah, I sat on a forum today that was organised by them, and it was brilliant. It's really good. Great.
Good.
Well, thank you very much for the presentation, Jonathan.
Thank you for your comments, Sam. Yeah.
Well, yes, I echo that. Thanks very much, Jonathan. It was really interesting. I'm sure everyone got a lot out of it. So if there are no other questions, it's nearly 7:15. So you can all go and enjoy the rest of your evening.
Go home.
Thank you very much.
Audrey.
Thanks, Cheryl.
Okay.
Thank you.
Well, thanks again, Jonathan, and thanks everyone for attending. And I will be sending out the recording tomorrow. So if you missed anything, you can catch up. Okay.
Thank you very much for your kind comments.
Good night. Thanks, Jonathan. Bye, everybody.